All right, last storm type is hurricanes. Hurricanes themselves are extremely powerful storms that happen. They hit our east coast in the south. They are actually known to hit our west coast as well. Not as common because of how El Nino and La Nina work, but we want to talk about hurricanes in this video. So watch the one-on-one video and then we'll jump into the details. All right, when it comes to hurricanes, this is our explanation. It's a whirling tropical cyclone. And this is, of course, where things start to get confusing because when we talk about cyclones, usually we're talking about cyclonic flow, changes in pressure, the causes of wind, different things like that. So why does this same term appear? And a lot of it just has to do with the fact that we have a word for these storms. Other parts of the world, they just call them cyclones because of the motion that is being made, right? The word typhoons can be used, cyclones can be used, tropical cyclones, all those things come into play here. But this concept, tropical, is key. That's where they start. They start in the tropics. Not as fast of wind, but definitely because they're much larger, that wind is sustained for a much longer time than a tornado. And you can see the formation of hurricanes. Here's in the, what am I trying to say? This is the Atlantic, right? Going this way. Here's the Pacific. Most hurricanes move this way, right? Carried by the trade winds kind of across that way, rather than the westerlies pulling them this way. Right? So we just don't get hit by as many on the west coast, but every now and then one will sneak in and get hit by one. Your average speed is about 75 miles per hour. Slow, right? Though I'm sure if you got hit by a wind that was looking like that, you would not enjoy that, right? Along with that, right, it's because they form over water, you're going to get gigantic waves, right? 15-meter waves, that's 3 feet per meter, right? So extremely strong winds. Tall waves that can lead to flooding and different things like that. As we think about the United States, we get this reality, right? 50% of our population lives near the coast. And because of that, most of them are East Coast more than West Coast. They get hit by these things, right? All the way from Florida up to, well, they hit New York City. Big storms like that have done it. So they can go up pretty far and cause some pretty devastating amounts of damage. Where do we see this happening, right? Here's kind of our large belt, right? I talked about this is where we see them the most, right? They can form here, but most of them in the Pacific end up here in this part, so China and Japan and these island countries, and then you get Indian Ocean and around Australia can get hit. Not really too many forming down here, all right? Mostly because of how the air is moving. That tropical air moves and then gets pushed back. It just doesn't form there, right? It doesn't form there, okay? While lots form each year, very few actually get to that hurricane status. So lots of tropical storms start spinning, but most of them dissipate before they get anywhere close to land or an island or anything like that as we look at that, right? Fewer than 5 hurricanes per year, right? This statistic might be a little bit older. It's starting to get a little bit bigger. They're saying 6, 7, maybe up to 10. We don't hear about most of them because they're not, because like we said, they dissipate, they go away before they actually hit the states. But nowadays, typically we hear about 1 or 2 hitting the southeast. All right, let's talk about how these things actually form. Right? First of all, to form a hurricane, you need water vapor, right? And as water vapor condenses, it gives off heat. Right? So as it changes from that gaseous state into that liquid state, it's giving off heat. Because you need that, you need the water, you need the heat, this is when they have a tendency to happen, right? From early spring to late summer, Ocean temperatures have that warm water to continue fueling them and give you that heat and moisture that's going to happen. And as you look at this picture, right, you got the heat and the moisture, it builds up. We got the trade winds bringing them this way. And then about the time you get, just into this area, this is where the spinning might start occurring. And then if they don't get, right here come the westerlies, if they move up, usually then they get pushed back this way. If they come in stronger, then they actually hit the continent before they get pushed up. All right, here's the steps. Step number 1, all right, jot these things down. Starts as a tropical storm, very disorganized, little to no rotation, right? It's just the movement of the air, right? The humid air is condensing, you got warmer air rising, right? The winds that are just coming from there might have the thunderstorms being developed within this structure. Number 2, right? They are low pressure systems. And as that happens, now the air is going to start rushing in. And as it starts to rush in, right, so here you got this low pressure forming, the air is going to start rushing in. As it rushes in and rises, then we get the rotation that starts to begin much higher up in the atmosphere. And you start to get these little, kind of these channels. You can see where there's clouds and then there's breaks like this, right? And those are important as we look at that. I believe the label comes up in a future slide. As these updrafts happen, you start to get kind of different spirals along the way within this cumulonimbus cloud, right? Not a mesocyclone, just the clouds starting to spin, right? As it gets bigger and bigger and bigger, this is where we get what's called the eye wall, the wall itself. So this is where the main rotation happens, right? When we look at the pictures in a minute, we get the highest wind, the most amount of rain right on the sides here of the different, this is the eye wall, right? As we look at that, and then this is the big storms right here. Right? When you're in the eye, you can see that precipitation and the wind subside. It's one of the craziest things is you'll hear about people who are down in hurricanes and they will literally come out of their houses, have a party in the middle of a hurricane, and then get back inside by the time you shift from one part of the hurricane to the other. It's crazy to me because I don't live there, but I've talked to people who do live there, and they do that. They literally will have parties in the middle of a hurricane because of that. But as you're looking at this picture, you see a lot going on, right? You got updrafts, downdrafts, updrafts, downdrafts, and then this air cycling around as well, creating this just massive spinning air as we're looking at this, okay? And so this is what we start to see from satellite imagery, right? We can see the eyes, very easy to identify, right? And then we got this picture, right? We got the eye wall in the center surrounding the eye itself. We have what are called rain bands that are separating these kind of different layers where you get the updrafts and the downdrafts in between them. You have the outflow on the top part, which creates this gigantic cloud that we're looking at as it's spinning counterclockwise. We know that because that's what low pressure systems do in the northern hemisphere, right? In the southern hemisphere, they're spinning the opposite direction. So we have this, right? Fill in the details on your notes about this, right? Get your eye and your rain band, your eye wall, identify your warm and your cold air as you're looking through this. When it comes to intensity, right, we use what's called the Saffir-Simpson scale, right? So that's how we start to measure them. Is it a class 1 hurricane, class 2, 3, 4, 5? The Saffir-Simpson scale is what we look at, right? And so you're going from wind speeds of about 75, that's your class 1, and then you slowly kind of increase by about 20, 25, maybe not quite 25, 20 miles per hour till you get to about that 150-ish range, and those are going to be your most powerful winds and your largest storms as they come in here. Damage increases as you go up, right? From very minimal damage to catastrophic damage where trees literally will get pulled up as you work through it. One of the most dangerous parts about the hurricane is actually what's known as the storm surge, right? And a lot of it has to do with pressure, right? As the hurricane moves through, you get this low pressure system that comes in, and the water and all the air it's almost like the water literally will leave and go away from the land, and then it builds up into this large amount of water. Not quite a tsunami, but it's a similar process of what's happening. And then when the pressure changes, now this big wall of water that's building up deeper in the ocean as it moves towards the land, right? As the land goes from deep ocean and then slowly rises close to closure, now you get this big wall of water called a storm surge that will push, right? And this is where it goes over all your levees, into your streets, right? Giant wave of water that just comes crashing in. And this, to some degree, is more dangerous than the storm itself, right? If you lock yourself in your doors and you do all the things you need to do to keep yourself inside the house, great. Usually you're pretty safe in your storm, but it's this is what people often forget about and will actually kill people because they think the storm's over, and then you got this giant wall of water that comes rushing in to the area as the storm hits. It can cause a lot of damage. All right. So you have this concept, right? Quick pictures, right? As hurricanes have come through along the way. Devastating, right? Devastating. In the end, why don't we get hurricanes? Because of this concept right here. Hurricanes need water. No water, storm goes away. Right? So the instant they come up and they hit land, they lose access to that water, they lose access to their fuel source, and they break apart and stop being a hurricane, right? All right, final thoughts. When you start looking at some of these things, sometimes you can see some of these kind of terms coming in. A bomb cyclone is often confused with a hurricane. It acts like a hurricane on the west coast, but it's not an actual hurricane because it's not powered by water. It's almost more like a mid-latitude cyclone that has the effects of a hurricane. And they're really, really fast storms that happen in the northwest of the United States, which is where the term bomb comes in as you look at things. This last one, known as a hypercane, this is not real, right? But this is what all the movies, this is what climatologists who want to talk about doomsday focus on, is that hurricanes are going to get so bad that they're going to create basically super hurricanes that will be hurricanes that are the size of continents. I'm not sure if that's how God's going to do things, but it makes for an entertaining movie. That's our severe weather.